Welcome back. In the last video, we functionized our training loop. So now we can call this train step function, and instead of writing all this training loop code again, well, we can train our model through the art of a function. Now, let's do the same for our testing loop. So I issued you the challenge in the last video to give it a go. I hope you did, because that's the best way to practice PyTorch code, is to write more PyTorch code. Let's put in a model, which is going to be torch nn.module. And we're going to put in a data loader because we need a model and we need data. The data loader is going to be, of course, the test data loader here, torch.utils.data.data loader. And then we're going to put in a loss function, which is going to be torch nn.module as well, because we're going to use nn.cross-entropy loss. We'll see that later on. We're going to put in an accuracy function. We don't need an optimizer because we're not doing any optimization in the testing loop. We're just evaluating. And the device can be torch.device, and we're going to set that as a default to the target device parameter. Beautiful. So we'll put a little doc string here. So performs a testing loop step on model going over data loader. Wonderful. So now let's set up a test loss and a test accuracy, because we'll measure test loss and accuracy with our testing loop function. And we're going to set the model into, I'll just put a comment here. Put the model in eval mode. So model.eval. We don't have to use any underscore here, as in model 0, because we have a model coming in the top here. Now, what should we do? Well, because we're performing a test step, we should turn on inference mode. So turn on inference mode context manager. Remember, whenever you're performing predictions with your model, you should put it in model.eval, and if you want as many speed ups as you can get, make sure the predictions are done within the inference mode, because remember, inference is another word for predictions within the inference mode context manager. So we're going to loop through our data loader for x and y in data loader. We don't have to specify that this is x test or y test. We could if we wanted to, but because we're in another function here, we can just go for x, y in data loader. We can do the forward pass after we send the data to the target device. So we're going to have x, y equals x.to device. And the same thing with y. We're just doing best practice here, creating device agnostic code. Then what should we do? Well, we should do the thing that I said before, which is the forward pass. Now that our data and model will be on the same device, we can create a variable here, testpred equals model. We're going to pass in x. And then what do? We can calculate the loss. So to calculate the loss / accuracy, we're going to accumulate it per batch. So we'll set up test loss equals loss function, plus equals loss function. We're going to pass it in testpred and y, which is our truth label, and then the test acc, where you will accumulate as well. Using our accuracy function, we'll pass in y true equals y, and then y pred. What do we have to do to y pred? Well, our testpred, we have to take the argmax to convert it from, so this is going to outputs raw logits. Remember, a model's raw output is referred to as logits. And then here, we have to go from logits to prediction labels. Beautiful. Oh, little typo here. Did you catch that one? Tab. Beautiful. Oh, look how good this function is looking. Now, we're going to adjust the metrics. So adjust metrics and print out. You might notice that we're outside of the batch loop here, right? So if we draw down from this line 4 and we write some code here, we're still within the context manager. This is important because if we want to adapt a value created inside the context manager, we have to modify it still within inside that context manager. Otherwise, PyTorch will throw an error. So try to write this code if you want outside the context manager and see if it still works. So test loss, we're going to adjust it to find out the average test loss and test accuracy per batch across a whole step. So we're going to go length data loader. Then we're going to print out what's happening. Print out what's happening. So test loss. What should we put in here? Well, we're going to get the test loss. Let's get this to 5 decimal places. And then we're going to go test ac, and we will get that to 2 decimal places. You could do this as many decimals as you want. You could even times it by 100 to get it in proper accuracy format. And we'll put a new line on the end here. Wonderful. So now it looks like we've got functions, I haven't run this cell yet, for a training step and a test step. So how do you think we could replicate, if we go back up to our training loop that we wrote before, how do you think we could replicate the functionality of this, except this time using our functions? Well, we could still use this for epoch in TQDM range epochs, but then we would just call our training step for this training code, our training step function, and we would call our testing step function, passing in the appropriate parameters for our testing loop. So that's what we'll do in the next video. We will leverage our 2 functions, train step and test step, to train model 1. But here's your challenge for this video. Give that a go. So use our training step and test step function to train model 1 for 3 epochs and see how you go. But we'll do it together in the next video.